So in this lesson, we're going to look at what it means for figures to be similar. And we're not going to worry about a strictly formal definition of similarity. Informally, similar means similar figures have the same shape but perhaps different sizes. We've seen a lot of similar figures when we were doing the dilations unit. You remember when we were scaling figures up to get bigger or scaling them down to get smaller? The results are always similar. Now we're going to see later in this unit similar figures that are assembled in more complicated ways than the simple way here, where they're twisted around, where the problems become more challenging. So it's important to get the basics down really firmly here. So here I'm intending these two triangles to be similar. This is a smaller version of this larger one over here. They have the same exact shape. All the angles match up perfectly here with here, but they're different sizes. The notation for similarity is a lot like the notation for congruence. Here I have triangle ABC, and I'm going to say it's going to be similar to triangle XYZ, and the order here is important. Just as with congruence, the order shows how they correspond. It shows that angle A is going to be the same as angle X. It's going to show that AB corresponds with XY. The notation looks like the congruence notation. It's just the tilde part. This is the notation for similarity. So this would say triangle ABC is similar to triangle XYZ, and the order here reflects the correspondence. AB matches with XY. AC corresponds with XZ. When we have similar figures, corresponding angles are congruent. They have exactly the same measure. However many degrees this angle is here, this angle which corresponds with it will have to be exactly the same. If the angles were different, they wouldn't have the same shape. But corresponding sides, unlike with congruent figures, corresponding sides don't have to be the same length. AB is not the same as XY. The word here is corresponding sides are proportional. And I want to show you on the next piece of paper what I mean by that, how we're going to work with that, what that means. So when I say corresponding sides are proportional, let's look at this. Here I have those triangles again. Triangle ABC is similar to triangle XYZ, and I've added some measurements here. So what I mean when I say corresponding sides are proportional is it means that if I take a ratio of corresponding sides, it's always the same. AB to XY is the same as BC to YZ, is the same as AC to XZ. That's what I mean when I say corresponding sides are proportional. The ratio of corresponding sides is always the same. So when you're doing problems, like here in this, we're going to figure out what these missing side lengths are. We're going to figure out what BC is. We're going to figure out what XZ is. When we're doing problems, what we do is we look for two corresponding sides. Here AB corresponds with XY. I look for two corresponding sides where I know both measurements, because that will establish the scale factor between these two figures. The fact these correspond, and the fact that this is length 8 and this is length 20 tells me that the scale factor here is 8 to 20 is the scale factor. And we can reduce this to make our life easier. 8 over 20, if I divide the top and bottom by 4, is the same as 2 to 5. So that means there's a 2 to 5 scale factor going on between the smaller triangle and the larger triangle. So now I can set up proportions to figure out the remaining unknown sides. So since I know the scale factor is 2 to 5, I can say 2 to 5 is the same as this unknown shorter BC to its longer partner 32. Since I know 32, I can figure out BC, and I figured out the scale factor. If I cross multiply this, I get BC times 5. Oops, let's move this over. There we go. Is the same as 32 times 2, which is 64. And then dividing both sides by 5, I get BC is 64 divided by 5, or what is that? 12.8. Likewise, I can figure out xz. The scale factor is 2 to 5, so 2 to 5, smaller to longer, is going to be smaller 15 to the corresponding longer side xz. And if I cross multiply this, I get 2 times xz equals 75. So xz is 75 divided by 2, and that is 37.5. Here's a slightly more complicated example where I've put one triangle inside the other. So I'm telling you the similarity. ABD is similar to ACE. Then I give you all these different lengths and ask you to find some other lengths. So the first thing I'm always going to do is I'm going to take these lengths and I'm going to put them in the picture so I can see what's going on. So AB is 12, BC is 3, DE is 2, CE is also 12. And I need to figure out those two lengths. One of the keys here going on as the problems get more complicated and the triangles are put together in more complicated fashions is to take the two similar triangles and put them side by side so they visually correspond. By visually correspond, what I mean is I'm going to label these two triangles so that this correspondence is visually clear. A with A, B with C, D with E. So everything matches up visually. So I can see the correspondence just by moving my eye left to right here. So this is going to be my smaller triangle ABD, which is just going to be a copy of this. And this is going to be my larger triangle, and I'm going to write the letters on this so that they correspond according to this correspondence here. So since this one ABD to ACE, this has to be ACE, which is also the order in the picture. But in later problems, as this is more complicated, these triangles will be twisted around in funny ways, and it'll be harder to, you'll have to use the correspondence down here rather than looking at the picture. So now what I will do is I will move all my measurements from this picture down to here, and then I'll set up a scale factor and answer the question. So let me move my measurements. So here this is 12. This I don't know, it's just BD. This I don't know also, that's just AD. The bigger one, A to C, is this whole distance. That's 12 and 3 more, so this is 15. C to E I know is 12. A to E is an unknown AD and then 2 more. So I'm going to call it that. It's AD plus 2. The key to this is now I can see how things correspond. 12 corresponds with 15, BD with 12, so on and so forth. So now I can read my scale factor. My scale factor is 12 to 15, which reduces to 4 to 5. So now, just like in the last example, I can set up proportions and solve. Let's do AD and AD plus 2 first. 4 to 5, that's my scale factor, is shorter to longer. AD over AD plus 2. If I cross multiply this, I get 4AD plus 8 equals 5AD. So AD is 8. And then my other one, BD and 12, BD is the shorter, so it goes on the top, 12 goes down here. Cross multiplying this, I get 5BD equals 48. BD is 48 divided by 5, which is 9.6.